has not been wholly helpful in terms of my clarity. So I'm proposing that we do this activity at this time and around this time every Wednesday and Thursday for as long as you want, right up until the exam. You know your exam is on the 8th of May, starting 9 o'clock in the morning. I'll send everybody the exam by email as well in case you have problems accessing MLS, depending on where you are in the world. The exam's open for a 24-hour period to take account. Yes. Thank you. Bandwidth problems, I think. Let me just quit Discord. Right, hopefully you can hear me much better now. Sorry, Robert, I just forgot in the chaos. So I really wanted to start from, can you hear me okay now? Yes, thanks. And why not? You can't see the screen. Everyone else, there should be a screen with 3 files on it: air pollutants, petrol additive, and statistics summary. Okay. So just while Andrea does the refresh, what I was expecting to do today was to cover, and I think I've probably just got about time to go through everything, was to cover data distributions, box plots, normality tests and its hypotheses, one sample t-test, and then tests for independent and paired data. And then tomorrow I wanted to cover the rest of what we had on the list, which was ANOVA's correlation and regression. And my proposition then for next week was to effectively walk through the exam. Sorry, not the real exam. The mock exam. Walking to the real exam would probably make the exam a little bit easier than I had in mind. Okay. Just not convinced. I think everyone's with us now except for Alistair. Sorry, not Andrea. Let me open up. I'll get one of these data sets loaded while we wait. Oh, that's really frustrating. Well then, Animesh, if you're recording it. Oh, okay. So thank you, Animesh, for recording this. I hope you don't catch the first hour. There wasn't an awful lot of value in that. The duration of the test. So the exam is designed to last 2 hours. So there's 4 questions in it. Each question would take you, I would imagine, about half an hour to do. The reason why it's available for a whole day is that not every student is available in the UK on the 8th of May. So there's different time zones, and also people with caring responsibilities. For example, you may not be able to do it at 9 o'clock in the morning. So it gives you the option to do it whenever, but the idea is that you're meant to spend roughly 2 hours on the exam. I can't see there's much value in spending 24 hours on it. It's been designed for a 2 hour pleasurable experience. Putting me on the spot there, Sean. The guidance we've had from the university is you should be spending approximately the same amount of time to try and get it to be a roughly approximate examination experience. I think if you were 10% over, that's probably quite reasonable given the distance working. Does that answer clearly enough? Well, I think okay. So to answer those 3 queries from Sean and Lee and Tabby, so Sean, if there was a restart, and this is why it's not running for a tightly defined 2 hours. I think approximately 2 hours of effort directed towards the answering of the question. So if you had to restart a question for system crash or whatever, then that might mean that you can sort of extend the time out. Lee and so Lee's question's easier than Tabby's. I think, Lee, that there's normally an additional 25% is typical. So that's easy enough for you to self-regulate. Tabby, that answers the first half of your question. I think you can get a guide from SES as the additional time available, but my recollection was it was normally an additional 25% or 50%. SES can clarify with that. Additional help, I think we'll need to take that one offline, if that's all right, Tabby. I'll make some inquiries with our head of teaching and learning because it's a slightly unusual situation. Are there any other organizational questions on the exam? Yeah, I know, SES are overloaded. That's why I'm going to pick it up directly with our school head of teaching and learning and get some advice direct from her. The SES are struggling because they're getting emails from every student in the university who can't use a bit of technology. Much like myself, some of the non-technical students would, maybe struggling with some of the distance learning tech, so having to support a wide range of different issues at the moment. All right. Assuming there's no other questions on the organizational aspects, I'm going to just skim through this quickly. No, that's not very helpful. I'll try that the other way around. No. All right. So the way I fixed Bongo was to not use my machine. This machine has been set up a little bit differently. I think what I'll do is I'll just use it like this in full screen. It's easy enough to see. You can see that okay, yeah. Right. So the exam structure, there are it's the way I wrote the mock exam for you, I put it on the exam template. So the where are we on the PowerPoint? Oh, yes, it's because I'm not using my machine. I'm using my partner's machine, and she's very kindly done other stuff. That that was my fix. So obviously, using her machine, it then triggers. Anyway, well, this has just been a real adventure. It is. It's not part of the stats class, Animesh, but since you're recording the lecture, I'll answer the question. Originally, yes. Uh, she has Polish ancestry, but he is German. But there we go. Brief interlude into my personal life. Right. So the exam, 4 questions. Each question is equally weighted. So there's equal marks. That's not to say that every question is exactly the same length. Some of them are a little bit more work than others, but I've made them an equal length. The data is the Creative Nations data set, and so I didn't want to get into that today or tomorrow, but I will do next week when I walk through the exam solutions. Okay. We covered way back in week 9, and that was the last of our classes. And I must say, it felt very odd just to have such an abrupt end to the teaching. I didn't even get to say, the exam in person or anything. We covered the types of data, measures of spread. In fact, I went through this presentation, and we focused particularly on the normality test and t-tests in general for independent paired and one sample. We also covered the Mann-Whitney and Wilcoxon sign rank test the following week, and that's really the scope of what I wanted to go through today. You'll recall that there are principally three types of data. There's numerical data you can actually measure. They might be whole numbers, so the number of observations, for example, of a particular event, or there might be a continuous measure, so the height of people, the weight of people. These things have decimal numbers. And in SPSS, you can tell if the data is numerical by looking at the variable view, and if it has a scale value, the ruler, that makes it numerical. The categorical data is either ordinal or nominal, and the clues in those words. Ordinal means it has a particular data order to it. So, I don't know, t-shirt sizes, small, medium, and large. Yes, they're words, but they're words that have a particular order. Whereas nominal is just arbitrary labels, red, green, blue. And what you'll see in the examination data is that we've set that up for you, of course. So you don't have to worry about that aspect. It makes a difference for the tests because when you're doing, for example, an independent data test, you need to specify the grouping variable. That grouping variable will either be an ordinal or a nominal. And likewise, if you have to do a correlation, you either do a Spearman's correlation or a Pearson's correlation. The Spearman's correlation is used when one or both of the data sets are not numerical and not scaled data. So if you're asked, this is probably a useful thing to make a good note of. If you're asked to do a correlation, then if you look at between two things, if you look at what they are on the measure aspect of the variable view, you'll be able to tell if it's a Pearson's correlation, because they'll both be scale values, or if it's a Spearman's correlation, because one will, or at least one of them will be either ordinal or nominal. I don't believe there's any ordinal data in the Creative Nations set, so I think one of them would be nominal, and if either are nominal, then that would mean that you would do the Spearman's. Okay. Let's get back to the presentation. We also spoke about measures of central tendency, mode, median, and mean. The mode is just the most frequent in any data. The median is obviously just the value in the middle, and the mean is the numerical average. Another useful tip is that the mean is only meaningful when you're talking about normally distributed data. If the data isn't normally distributed, then the median is a better measure of the middle value. And I'll give an example of why that is later. We also talked about quartiles, where you would rank order the data. And what I mean by rank order the data, this is a slide that I added in this morning while I was preparing for this highly successful class. Here I have a random set of 21 values. It doesn't matter what they are. You then rank order them, so you simply put them, obviously you don't need to do this in exam, you put them in the right order, and then the Q1 position is a quarter of the way along. Q3 position is 3/4 of the way along, and the Q position is half. So that's all that's meant by ranking the data. And those quartiles then give you a reasonable measure of spread. So the Q2 is the median value, that's the middle one in the list. And when you look on a box plot, that median value is that thick line there. Q1 and Q3 are these lines here, so the lines around the edge of the box. Go back. And so what you have is then the box plot gives you a measure of the spread, because 50% of the data, the middle 50%, sits within that yellowish box. All right. We spoke in the class about range, where we spoke, if you recall, about age ranges in the class, and then you might have an outlier like me who's too old to both use Bongo and Discord, and that might skew the distribution. And SPSS shows outliers in its box plots quite helpfully with these little circles. So I don't know how well you can see it, but there's a circle there, and next to the circle is the number 27, and that's the row that the outlier is on in this particular data set. It calculates the outliers in a particular way, which we'll come back to. So the interquartile range is probably better than the range because it deals with the 50% of the central data, and then of course there's the standard deviation. The standard deviation is only useful when the data is normally distributed. So let me just explain why. So here we have a normal distribution, and you can see the data is in this sort of curve. My hand is steady than it looks on the screen. And the mean is that center point, and because it's normally distributed, it's spread evenly on either side. So, for example, if you were to look at the heights of all of the men in the class, it might look something like this. But that's not the only distribution that's possible. You do get other distributions. So this multimodal one, if we were to look at the heights of all of the people in the class, you might get a different peak for men and women, for example. Here we have what's called a uniform distribution, where there's no difference in the likelihood of getting one value or another. And this bottom left one is sorry, the bottom center is what's called a skewed distribution. It's just skewed towards the right. It could be skewed towards the left. And you can see those sort of patterns of distribution when you do the box plots or indeed scatter plots. Just a brief note here on what might cause outliers. It's nothing that needs to be thought of in the exam, but it's just for reference. Sometimes it's a typo. Sometimes it's an unusual circumstance. Sometimes it's a genuine outlier. And often statistics wants to get rid of outliers because they make the analysis a little bit harder. So here's a slide on the standard deviation. Looks harder than it is. All it's saying is the standard deviation is a measure of the difference between every point. The sort of the funny E there, which is a symbol that says that you're going to look at all of the values within the range. So from 1 to n values. For all of those values, calculate the difference between the mean, which is the x with a little bar on the top, and the particular value, in this case x subscript I. You square that to get rid of the sign difference, divide by a measure of the total number of data points. And so you end up with the same kind of curve. There's 3 examples there that can all be described by 2 parameters. One is the mean, which is where the middle line is, and then the second is the spread, which is just how wide ranging it is. And so the t-tests work on comparing these distributions. They build a distribution based on the data and see if those distributions are broadly the same. Are we okay so far? Obviously, if there's any questions, just dump them in on the public chat, and I'll stop as we go along. All right, so we get then onto hypotheses. This is maybe a little bit complicated, but it's much easier than it sounds. In short, I'll come back to this slide, but basically the rule is for the normality test, yeah, this is me struggling with bandwidth. I think that's why it sounds a bit iffy. For the normality test, the null hypothesis, the H0, is always that the data are normally distributed, and the alternate is that the data are not normally distributed. And for all of the other tests, the assumption is that the null hypothesis is that the groups being compared are equal. Doesn't matter whether it's an ANOVA or a Mann-Whitney or a paired t-test or whatever it is. That's always the way that you organize the hypotheses. And then from the test, you get a result. That result is this crucial p-value. It's shown in different ways in different examples. There's always this 5% threshold, and that gives you the chance that the null hypothesis, this notion that they're equal, is true. So if it's quite high, then they're more likely to be equal. And in fact, you can test this in SPSS if you put in two data sets. Exactly one as a p-value, because there's no difference between the data. Okay. I think now I'm going to switch to SPSS with one of the examples. So here we have a trivial example of two data sets. Just focus on the first two columns to begin with. So this is to do with miles per gallon and petrol. And there's an additive that you can put in your fuel that is meant to improve your miles per gallon. So this has then been tested on 8 different cars, and the miles per gallon have been recorded with and without the additive. So when you're approaching these exam questions, it's usually helpful to start with a box plot. And so we've really got 3 buttons we need to worry about. One is graphs, which is for doing all of our graphs. One is analyze, which is for doing all of our tests. And one is transform, which is for computing variables when we need them. And for the exam data, sometimes you have to do the select cases, which we'll talk about next week, not this week. I'm going to start with a box plot. I always go through legacy dialogues because you get an explicit list of charts you're looking for. And in GRS501, we're only really interested in 2 types of charts: box plot or scatter plot. We use a scatter plot if it's a correlation question. You can tell if it's a correlation question if the question is framed as one thing related to another. For everything else, I'd like you to use box plots. So we always keep our box plot options on simple. This has caused a little bit of confusion in terms of the data in the chart area. 2 different options here. One is summary for groups of cases, and one is summary of separate variables. I'll show you the groups of cases when I get to the next example. I'm just going to focus for now on summaries of separate variables. What that allows you to do is to put multiple variables in the same box plot. So you can add in all of these different variables. I'll come back to what this without alt is shortly, but you can add that in as well, and you can put 3, 4, 5, 6, as many as you want in principle. It becomes very difficult to read if you put too many in. You hit OK, and there's our exciting box plot. But you can see quite a lot from the box plot with the additive and without the additive. You can see that with the additive, the median is a little bit higher than without. Both data sets have got a little more wide-ranging values at the lower end rather than the upper end. And the body of data is largely overlapping. So if you were to ask, does the additive make a difference? I think it would be difficult to tell, actually, from that box plot. And that's where the statistics come in. can go back to our data sheet here. So, you normally start one of these questions with a box plot and a little bit of narrative around what that box plot's showing. We want to compare whether or not the additive made any difference with and without. And so row 1 is one car, row 2 is another car, row 3 is another car. So this is then a paired test, because it's a before and after kind of thing. It's two different conditions on the same car. So here we have, for example, in row 6, a very fuel inefficient car. It's only doing 23 miles to the gallon without additive, whereas the one below it, 54, is much more sensible. That's probably a better car to own if you want to save some money. That's doing a much higher miles per gallon, and so the absolute value doesn't matter. What matters is that the 23 has now become 25, so it's an increase of 2. Or the 54 has stayed the same, it's an increase of 0. Or in the bottom case, the 46 has now become 53. And so we know it's paired, but we need to determine whether or not to do a paired t-test or a Wilcoxon test, which is the non-parametric equivalent, the test you would do when the data is not normal. In order to determine the normality test, because this is paired data, we're going to have to compare, we're going to have to work out the difference and do the normality test on that. The difference is calculated by the transformed compute variable. I'll call it difference. Have it as 1 minus the other. And so you can see in this very simple example that we now have a difference of 4, 1, etc., etc. You can see what's gone on there. It's just one column minus the other. And then we have to do the normality test on that data. The normality test is quite difficult to find if you're not familiar with it, so do make sure you remember how to do this, because almost every question will require you to do a normality test. It's Descriptive Statistics Explore. Don't get baited into the helpfully called button statistics. The test you want is actually in plots, and we want to do that test on difference. Now, annoyingly, SPSS has made this difference default to a nominal variable, but it doesn't actually make any difference for the calculation. Untick the stem and leaf, otherwise you get lots and lots and lots of plots. And we click normality test. Okay, we get our first statistics result. Would anybody in the chat like to hazard a guess as to whether this data is normally distributed or not normally distributed? To help, I shall bring up the slide. Is the data normally distributed or not normally distributed? Normally, good. Yeah. B is bigger than 0.05, so normally distributed. You imagine in the panic of the exam, you can't remember how to interpret a normality test. Well, helpfully, there's an example. Oh, yes, Lee, very good point. The scale of data that we're looking at, the Shapiro-Wilk, is the one to look at. The other test, which is evidently named after a Russian vodka rather, provides a similar outcome. The data is not significant, but it's less confidence, and it's because this test here works better on very large data. Yes, vodka. I've been in Scotland too long. Whiskey's the default choice. Shapiro-Wilk is Or was that a question, what's vodka? I'm not sure we've got time for that, probably beyond the remit of the class. Here we have the significance value that we're actually interested in. So our data is normally distributed. Because our difference is normally distributed, we can go back and do a paired t-test. Now you find all of the t-tests under the Analyze tab, and they're all under what's called compare means, and this is because the t-tests are assuming a normal distribution, and it's the difference between the means relative to the spread deviation. So we have our one sample t-test, which I'll come on to in a moment, independent samples t-test, and a paired samples t-test. And this one's obviously paired because it's before and after. So we click on paired, and you just put the two variables in. And hit OK. And you get your paired result. So you can see from this bottom list here that this value is below 0.05. Therefore, there are significant differences between those two data. I'm going to show you a slightly different data set, which is, this is without additive, but this is an alternate set here. So I'm just going to quickly redo the normality test. You can see that in spite of the bongo issue, I did actually prepare for the class. So I did make some data that might be useful. What I want to do rather is look at this without alt instead of without additive, because this difference here is going to lead to a different outcome. I'm going to recompute the variable, but instead of additional, I'm going to have alt. It's just a different data set that I'm going to use to illustrate where we get a non-normal distribution. Change the existing variable, yes. So now I have a very different distribution, and you can see what I've done is made a lot of the values the same. If we do the normality test on this instead, sure this is still clicked, we end up with a very different significant value. And because p is less than or equal to 0.05, we have a significant difference. Therefore, this data, the difference is now not normally distributed. Okay? Which means we can't do this paired t-test here. We can't do this one. We have to do the non-parametric equivalent. And again, I normally go through this particular option. We have two related samples. By default, it's the Wilcoxon one, which is the one we're interested in. We have the with additive and without, but the alternate data set, the one that I slightly modified. We hit OK, and we now end up with a different result, which is now being shown as above 0.05. There is no longer a significant difference. And again, if you're unsure where to look for that result of the paired t-test for non-parametric, to Wilcoxon rank, it shows you how to do it. That's just the menu set that I click through. You have your two variables, and then it highlights which one to score. Clear enough? Okay. Next thing I want to do with this data set is explore two questions that relate to a one sample t-test. So let's pretend that the sector average for all cars without the additive is 45 miles per gallon. The question can be asked is our little sample of 8 cars the same as the sector average. And so there we only have one reference data point and a single sample. But without the additive, so we're going to focus on this column here, is our data different to 45? Now, strictly for a one sample t-test, you should be doing a normality test. So we will do our normality test, but not on difference. We'll do it on with and without. And we end up with two data sets, both of which are normally distributed. It took me longer to make the data sets so that they gave me the pattern of answers that I wanted than it did to think through the question. They're both normally distributed. We can do an independent t-test, sorry, a one sample t-test, because our question is the data we're interested in without additive, is this different to the sector-wide average of 45 miles per gallon? So we do that by a one sample t-test. Yeah. We're doing without additive. If you put a 0 in here, then you'll obviously get a big difference because you're comparing against 0. We want to compare against 45. We hit OK. Now you can see from the box plot that the median value is 43, probably 42. Gives a minimum of about 41. So I think, the chances are it's not going to be different to 45. Because there's a pretty good big spread around that mean as well. And there we are. We have in our significance test a non-significant value. So our mileage without additive data set is in line with the sector-wide average. Second test we can do, the second question would be on with additive. And just to make the numbers work and show you a different behavior, comparison here is the sector average miles per gallon of 55, is that different with additive? So again, it's a one sample t-test. We're now interested in with additive, 55. Run the test again, and now we get a significant difference. Obviously, the point of the data was to illustrate an example where there is not a significant difference from the sector-wide reference point, and one where there is. Any questions so far? Silence in the chat box. Not. Right. The other data set I wanted to look at was air pollutants. And you can see immediately that this is structured differently. Again, forget the alternate data set here. This is going to be for a different set of outcomes for normal or not normally distributed. Focus on this. We have pollution levels measured in a city, perhaps before the lockdown and after the lockdown, or it's two different chemicals, chemical 1 and chemical 2. It doesn't matter. We've got 10 samples of each. And so the question is, let's assume these are different chemicals. So this might be hydrogen, and this might be carbon dioxide. It doesn't matter. Are those two data sets different? These were the levels of pollution in a city, then just randomly sampled. Then these would be independent data. And you can see already that this data set has a different structure to it. The way that it's been structured is quite different to the petrol additive, which was done in columns related to different data. And what you'll see in the exam is we've provided you with two different data formats, one of which has been referred to as wide, which is where everything is in columns, which is useful for things like paired tests. And we have another data set where everything looks a little bit more like this, where things are structured into groups with a group label. In the created nation data set, that's usually region. So one of the things you've got to judge is which is the easier data set to work with, but we'll talk about that next week. Here we want to do our independent our independent test to see if these two groups are different. Let's begin with a box plot. And if you recall, last time we had separate variables because we had our with additive and without. This time it's groups of cases because of this grouping variable here. We hit define. The thing we want to look at is pollution level. Our category axis, the way that we want to split it up, is based on that chemical. See, this is a nominal value, so it's a grouping variable. We hit OK, and we get a nice, happy distribution. And you might imagine that these distributions are going to be a little bit different. You can tell there's a much lower median. There's a very limited spread here in data ranges, although it's fairly uniform on either side. This one is obviously much broader, has a higher median, much more values towards the top end. So based on that box plot, it would be very unlikely that these data sets were the same. Next step we have to go through is our normality plot. So here, because we now have a group, we need to have a factor list for our dependent variable. And you'll see what happens when I run the test. SPSS breaks it down into the different chemicals. Nitrogen and hydrocarbons, in this case it's group 1 and it's group 2. I should have said they're labeled in the variable view. And this is similar to what you see in the exam data. It's just words to help you remember which sector's which, or which region is which. Go back to the output. And you can see that they're both normally distributed. In fact, one of them is almost completely normal, which is this second one. And that will be consistent with the box plot looking like an almost perfectly shaped, normally distributed data. Middle value bang in the middle and a pretty even spread on either side in the box plot and indeed in the whiskers. So there's always a relationship between box plot distributions and the answers you get here. So you can maybe try and second guess that if you've done something wrong. Okay. So we know that they're both normally distributed, therefore we can do the independent t-test to compare the two, which is always done through compare means. Independent t-test because they're not related, they're two different chemicals sampled in different ways. We're interested in the pollution level. Our grouping variable needs defined. I've helpfully called the groups 1 and 2. And 2. We run our test. And here we end up that, unsurprisingly, based on that box plot, there is a significant difference. Now, the independent t-test provides you with two different test results. One test, which it's more confident in, it runs a different algorithm where the variances are assumed to be equal. It runs another test when the variances are assumed to be not equal. This significance value here is not the t-test result. This is the result of whether or not the variances are equal. You can see that this is a significant result. You go back to this notion of these hypotheses. Always remind yourself of this, that if you get a significant result, then the things are not equal. They're going to be different. But what we have here is a set of results where the variances are not the same. You can see that from looking at the box plot. There's no way that the variation here is the same as the variation there. You're unsure how to interpret that test. We can go to our independent t-test. That's how to set it up. You get two results. If the test is higher than 0.05, then you read the higher row. In this case, it's higher. You read the higher row. In this case, it's below 0.05. It's lower than 0.05, so you read the lower row. It's the easiest way I can think to help you remember that. And I put an example of each on the reminder slide. And just going back to the exam, while I remember, you can have this PowerPoint there available to you. You can have any of the tutorial exams available to you. You can have the mock exam available to you. And indeed, the entirety of the internet. If you want to go and watch a video on how to do an independent t-test, then by all means do that. Probably not the best use of time. So our answer here is that we need to read the bottom row, because the lower row, because this is lower than 0.05. So we still have a significant difference between the two. If I were to do that test using my other data set, this alternate data set, we go through exactly the same process. We do our box plot and groups of cases, because we're going to have our grouping variable. But instead of this one, let's imagine the data look like that. And now we have a more similar overlap. The distributions are quite different. This one's quite skewed towards the bottom, but they're much more similar than they were before. That certainly doesn't look normally distributed. And if we do our normal distribution test, not on the original data, but on the alternate data used for illustration here, I run the test, and lo and behold, this one is as it was before, because I didn't change that data. This data set I changed to make sure that it was not normally distributed. So if we were using this data and wanted to see if there was a difference between these two chemicals, we couldn't use the independent test. We have to use the non-parametric equivalent, which is in two independent samples. The test by default is helpfully the one that we want to use, is the Mann-Whitney test. We put our variable in, which is of course this one. Our grouping variable here. The two groups are as they were before. We run the test. We get a response. Which of these many values do you need to read? Well, you go and check on the notes, but it's actually this one here. So we have a probability value of 0.88, which is much higher than 0.05. If you're unsure on how to read this, go to my helpful aid memoir that usefully circles which number to look at and reminds you whether or not that's significantly different or not. So now, having changed the data, we end up with a not significant data set, a not significantly different set of values. I've also provided in these slides a little decision tree. So you'll have seen now the mock exam, the kind of style of question. And these are questions that you ask yourself now to determine which test to use. So if the question talks about is one thing related to another, then it's going to be an association question. It's going to use this mix of tests. If it's asking is one thing different to another, bigger, smaller, has it increased, decreased, is it different, then it's going to be a mix of one of these questions. So if it's an association, and we'll cover these tomorrow, it's either Pearson's or Spearman's, and if it asks for a keyword of prediction, then it's going to be a linear regression. If it's a comparison question, probably most of them are as they were in the mock exam. If it's more than two groups, it's easy. It's always an ANOVA. If it's only in one group, if it's comparing with a reference point like the miles per gallon, is our data different to 55 miles per gallon, then it's also easy. It's a one sample t-test. Or it's this mix of other stuff. If the data samples are unrelated, then it's going to be one of these two tests highlighted in red. If the data sets are related, it's before or after, with and without, then it's going to be one of these two. Then if it's normally distributed through the Shapiro-Wilks, just to follow up with Lee's question, then the t-test is either independent or paired. Depending on whether it was unrelated or related, else it's not normally distributed, and it'll be the non-parametric counterparts, either unrelated or related. That's the decision process that you need to go through in the exam to work out which test to do. And then once you've worked out which test to do, as I said, I've given a nice screenshot of how to do every single test through the menus. And tomorrow we'll cover the ANOVA, post hoc Pearson's correlation, the Spearman's correlation, and the linear regression. That, incredulously, I finished on time, but that is what I wanted to really talk through today. There's only so much of this you can take through it, you can get through in one day. And I'm proposing to start again at 9:30 tomorrow morning on our newly working bongo, in order to cover ANOVAs and correlations and regression. Are there any questions? Yes, it is on MLS. I've made a couple of additions to the slide set, which I will add. Also, I'll reload that today. These pictures, I think this slide and this slide, I've added in. The rest of it's already there. But I'll re-upload to take in the new things, and I think it's called summary statistics. Let me see. I'm going to be careful not to go into anything confidential here, but I should manage to not screw this up. In your MProf submission materials, I'm just looking for it now, and I'll bring the slide over in a moment. So I need to just make that a new tab. So in week 10, I loaded this file, statistics summary. This is the file that is that set of slides, and the decision tree is in there. And there's just a couple of additional slides that I added in this morning. But there's the decision tree about halfway down through the file. That's available. Yes, this is the PowerPoint does cover all of the exam content. I will not ask you a question that cannot be answered by the mix of tests that we've covered on this slide that I'm highlighting here, or trying to highlight, but it's not working. This set of tests is going to be the scope of the exam. So all of the tests are known to you, the range of tests you have available, and the data is already known to you. It's the Creative Nation data. The only thing you don't have, obviously, is the set of questions. But the mock exam questions are similar in style and in format to the real exam. I can't think of anything that I could do to help. But I welcome suggestions other than giving you the actual questions, which would seem a little unreasonable. Was that a helpful thing, notwithstanding the debacle on my part for the first hour? That's an even better solution, Sean. I could turn the exam on its head. I could give you the answers, and then I could say, what were the questions? That would be a lot easier for me to mark. I only have a page to look at. Yes, that's the data, Alistair. I will do, Robert. I wasn't going to do that today. I was going to go through the whole mock exam next week, but I could do that tomorrow if you prefer. What I want to do in this first, see, you've had time to go through the mock exam yourself. You've had time to look through all the materials. I wanted to use this session just to reinforce all of the basics, and tomorrow just to finish that off in terms of a couple of examples of Hanover and regression with the underpinning correlation, and then use next week as the walkthrough for the exam, the mock exam. Now, obviously, if you have any specific questions that you don't want to share or you haven't yet thought of, email me. One advantage of working from home is I seem to be much more on top of my emails than I was when I was at work. So I don't think there's anybody that's asked me anything that I haven't been reasonably quick to answer, and hopefully the answers have clarified. I've got that impression. Any more questions? Was that format useful? Do you want just more of that tomorrow for the rest of the tests, just to get that baseline in place? Does this work? Stunned silence. Thank you, Josh. So in answer to Sean's question, if you get the question wrong with the process right, yes. So, there's normally a multi-step process if you happen to choose the wrong test along the way. So let's say that it's, you've recognized it's independent data, you've done the normality test, and you've misread the normality test in the panic of the exam, and you've said that the data is not normal, so you have to do the Mann-Whitney. Well, that's fine. You'll lose a mark or so for the misreading of the normality test. But if you then proceed with the correct set of steps with that wrong assumption, there won't be a cumulative penalty. You just lose out on the steps that you took wrong. Pain for me, because I have to walk through and figure out what you've done rather than marking it against my template, but I don't mind. It brings a bit of variety. Yes, you mean we'll do the mock exam walkthrough next week. I'll basically do the exam in front of you. I won't write all of the text necessarily, but I'll cover the main points. And can I again apologise for the technical difficulties in the first hour? That was clearly problematic. I think it's an issue with my machine. I will endeavour to fix it tomorrow. Otherwise, I'm going to make myself really unpopular at home. Okay, well, I think if that's everything. Oh, Bowen, yes. The mock exam is effectively a guide for the style of answers that I want, including the wording. Obviously, the wording's not exactly the same because you get different results, different trends, different spread. But that kind of template, use the mock exam as a template, basically. My recollection is, and let me just check on my other machine, is the 8th. I have to find it in my list. Main exam timetable. GRS501 is scheduled for the 8th of May, starting at 9 o'clock in the morning. The official exam timetable says from 9 until 1 minute to midnight on the 8th. As I said earlier, I recognize that some students are overseas, particularly in China, or might be at that time, where there's an 8-hour time difference. So I'm letting the duration run from 9 o'clock on the 8th of May to in the morning until 9 o'clock in the morning on the 9th of May. There'll be an option to submit the exam on MLS, through the normal container. But I would also ask that you email me the exam as well in case there's internet problems. I will send you the exam by email as well. A couple of students have flagged that they may have problems accessing it. And so you should please reply to the email that I send out to you with the exam. The resit procedure, Tabby, positive question at this stage. If you get an MF in the exam, a marginal fail, and you've done sufficiently well in the other unit that you can average a pass, you will average the pass. You will pass the module. If you get an F in the exam, you will have to resit. The resit is looking like it's going to be scheduled in July, but that's yet to be confirmed. It's also not clear whether we'll be open for resits to do in person or whether it'll be another exam online. I imagine we'll just do it in the same format. Is the exam recorded? No. Well, I can't tell how much time was spent on the exam. The guidance that I was given was to advise you to take approximately the same amount of time as you would do if you were sitting it in person. I think, given the nature of this, if it was like an essay question, then there's probably some advantage to spending 3 hours on every question. But I'm not sure how much more you could do with a lot more time anyway in this particular case. The question it maybe gives you a little bit more time to think about the words that you write down, but you've just seen me do 9 tests in 20 minutes. The tests themselves are a few clicks, a few buttons, and the results. Yes, for clarification, Lee, that is right. So you have to average a 1. You have to actually, I think it's a 1 and an MF. No, there won't be a timer in the exam, Akal. Yeah, if you average a D and as long as you get an MF, If you get an F, you have to resit. If you get an MF, then it just takes the average of the two grades. The grade weights for the exam and the coursework are 50-50. Perhaps not what you were hoping for, Alistair. You were maybe hoping for a 90% coursework and a 10% exam. But no, it's 50-50.